Hi, everyone. We are happy to see you at our Alert and Netdata webinar. We will wait a bit until everyone joins. Before we start, please take a look at a short poll we prepared for you beforehand. There are 3 questions. I would say pretty simple one, but your insights are very interesting to us, especially while the topic for today's webinar is incident management. Please answer your questions, submit your answers, and we will share the results at the very end of this webinar. And also, I'd like to address the first question of the poll to our speakers. Birol, maybe you can be the first. What is the biggest challenge our company, the team, are facing during the incidents?
I think, of course, we talk to a lot of customers, but if we look at our own infrastructure and our own the way we manage incidents, I would say is finding the right balance between, and I think a lot of companies can resonate with this, is finding the right balance between operational stability and delivery speed, right? Because changing things is the #1 root cause for incidents. And doing many changes, let's say you deploy multiple times within a week, you increase the likelihood for incidents, right? And there's a reason why people say never touch a running system, because if you don't touch it, you probably won't have any incidents. But if you follow this advice for too long, your customers will stop touching your systems either. So that's why what we say to our customers: embrace change, embrace the fact that incidents will happen, but be well prepared, right?
Thank you, Birol. I think many of our attendees can agree with your saying about the systems. Satyadeep, can you also share something on this question?
Yeah, I think I completely agree with Birol and the way he put it, right? But when I look at it a little bit more granularly, the biggest problem in incident management is the incident's response, right? In most cases, something has gone wrong. You might have had similar issues in the past, but basically, weighing your priorities between getting the root cause analysis to end versus just mitigating how big the incident is sometimes becomes a challenge. So do you want to collect everything that I need to analyze this later on versus just fix the problem for right now? It's more on the priorities. I'm just talking on the operations aspect of this. That in itself is a problem. And sometimes getting all the data you need for just a root cause analysis later. And that's why the SREs, the DevOps teams always have this conundrum. What do I do? Should I just fix the problem right now? And I think that's always the decision that you make. But while doing that, do I have sufficient data for me to go back to it later on? That's one of the common challenges, I think, with most organizations. What is the playbook that you follow when an incident occurs?
True. Thanks a lot, Satyadeep, for your input. I think we can kick off this webinar and start. For everyone who just joined, welcome aboard. We're happy to see you at our webinar. Don't forget to choose your answers in the poll. We will share the results at the very end of our webinar. I'm Daria, Partner Marketing Manager at Alert. Nice to meet you all. It's a pleasure. Today, we will talk about AIOps and how to leverage AI features to manage alerts and resolve incidents faster and more efficiently. We will talk and present live demos of 2 platforms, Netdata and Alert. And let me just say a few words on both of the platforms. Alert is the all-in-one incident management platform that combines essential features like alerting, on-call scheduling, status pages, to help developers across the globe to manage incidents quickly and efficiently. Our dearest partner today, Netdata, a real-time, high-performance on-premises observability platform designed to monitor metrics and logs with unparalleled efficiency. Netdata offers a simpler, faster, and easier approach to real-time, low-latency monitoring. It's worth mentioning that Alert and Netdata have a native integration, and it literally takes seconds to start using two solutions together. And that's why I really think that this webinar should be really beneficial to those people who already use NetData or Ilert. Our speakers today are Birol Eldiz, co-founder and CEO of Ilert, and Satyadeep Ashwathnarayana, head of product at NetData. We will have a Q&A section at the very end of this webinar. So please drop your questions in Q&A, and we will do our best to cover them all at the very end. And I give the floor to our speaker, Satyadeep. Satyadeep, please take over.
Thanks, Dario. Let me quickly start sharing my screen. Okay, first of all, thanks, Dario. Thanks, Birol, for having me on this webinar. I'm excited to talk to all of you wonderful people who've joined us in here. This topic in particular, when both Ilert and NetData were discussing on the possible webinar, is extremely close to my heart and close to the hearts of most of the people who have come in here. We're going to talk about AIOps and covering the whole spectrum from monitoring and observability to alerting and then incident management. Of course, the latter part will be covered by Birol and the Ilert team, and I will just start off with the monitoring aspects. Just on a funny note, what is the best incident management strategy? Is to basically never have an incident. An observability platform like NetData would always like to make sure that an incident never occurs, but in reality, we know that's never going to happen. So what do you do when an incident occurs? Just dividing them into three broad aspects. Detect early. So set up your monitoring and observability solutions so they inform you in time before a real big incident or an outage occurs. If you have, with all the wide AI capabilities available these days, can you have some anomaly detection and other AI LLM-based models that will help you in providing the trends of the way your infrastructure is behaving and thus detecting early and preventing a big incident. Most importantly, when the incident occurs, know your clear escalation paths. Which is the team that needs to work on this incident? Do you have all the experts on board and get them to resolve the issue and then find the root cause? The next aspect is, I think, where Ilert really shines, is to minimize the impact. Right? Do we have all the information as part of your incidents that are getting generated that can allow you to create fast mitigation actions? Like I was mentioning, you want to fix the problem right now, avoid huge impact of this incident, versus start looking at, what's the root cause? Let me go and find the reason right away. It might take minutes, hours, and we know the cost of an outage or an incident can be millions of dollars depending on your business and the type of industry that you're living in. Additionally, are there any automated rollbacks or failover playbooks that you have in place? I think Birol kind of touched upon this. Do you know if there was any software that was deployed recently? And if you're aware, is there a quick way to roll back? Do you have failover systems that are probably running on a previous release? Many of these are possibilities, but basically, this is where hopefully you have all of those playbooks on a system that allows you to take relevant actions. And then, of course, do you have predefined response playbooks? What do I need to do in a certain type of incident? What's the mitigation action? What are the types of data that you need to collect? What do you need to look at? What are the teams that you basically call upon? And then the last, which I think is the most important, is irrespective of how careful you are, you will end up with incidents, you will end up with outages. but what you learn and how do you prevent this in the future. Blameless postmortems. I like the terminology. It's always easy to point your fingers at someone else who might have been responsible for the incident, but how do you actually create blameless postmortems? How do you improve the situation so that next time, if such a situation occurred, what are the actions or remediations that you will take? And then basically have regular incident drills. This is something I remember, 2 decades in the past, we used to have these fire drills. We still have them, I'm pretty sure. But the post-COVID era, at least I have not been in the office for quite some time. But in principle, having regular incident drills, how your system basically reacts to incidents. Are we able to prevent outages? So there could be a part of the system that is impacted, but it should not impact your business. And that's where I think when we talk about monitoring and observability, it's not just about metrics of your applications or your infrastructure or your system, but how do you actually finally, uh, you know, draw the dots to your business KPIs? What is it and how is it that my business is getting impacted? So the next time I have very clear strategy on how not to impact my business KPIs. Just to touch upon the first aspect, which was monitoring, you need to have the perfect, if there is a perfect observability solution in place to avoid and mitigate all of these incidents that may occur. The current state of observability, we have a whole myriad of tools, observability solutions out there, and all of them in one way or another fall into one of these three categories. They either provide too little observability, or the observability solution itself is too complex, or they're pretty good in the sense that they're not too complex and they do provide me good enough visibility, but then they become too expensive. But all of these put together result in all of these aspects on the right hand side, which is either limited visibility because it is too little, late detection, because if you collect very little, you have very little data to go after, the detection of incidents and alerts are going to be late, and also will result in delayed troubleshooting. There could be performance bottlenecks in your systems and you are not aware of them, which finally would result in outages. And then if you have too complex an observability solution, it also then has other implications of reduced engineering efficiency. It takes a lot of effort to set it up. It takes a lot of effort to maintain and operate. So, every time an incident occurs, you need to add a set of new charts on your dashboard, or you need to start collecting new data and metrics. That is a complex action, and it's always reactive. It's very difficult to be proactive. And also it becomes more and more complex as your infrastructure grows. So maybe when you start off, all of your observability solutions are great, but the moment your infrastructure scales, it kind of becomes difficult to catch up with the growing infrastructure, with the hybrid infrastructure, the dynamic environments, the microservices architecture, for example, it just makes it more and more complex. Just a quick view of the various observability solutions, not to call out on anything. Each of them kind of in one way or another fall into some of the segments that I mentioned on the previous slide. There are some great tools, really great observability solutions. Some of them fall into the legacy. They've been there for decades. They've done their job extremely well, but they do come with, probably in the current times when you have all of these dynamic environments, limited visibility. They're not modern enough for observability. They may alert you from time to time, but then they do come with some of the limitations. Of course, there are some really great observability solutions out there, which on scale kind of become extremely expensive. So of course, if that's something that you're willing to digest, it's great. But in most cases, it kind of eats into your revenues and into your profits. So that's another section. And then finally, the custom solutions. This falls into the complex. They are brilliantly amazing tools. Kind of Netdata also falls into this open source ecosystem. All of these tools are great, but it just takes a long time for you to set it up. You need experts. You need a lot of expertise to put them together. But once you put them together, they kind of work really well. But to keep them going, managing and maintaining them over a period of time becomes more and more complex. Now, the whole foundation, especially in the current era of a great observability solution, happens to be around high fidelity data. Now, what is high fidelity data? So one is you collect data from as many data sources as possible. And two, you collect data as granularly as possible. Can you collect data every second? Can you collect data every half a second? So the more data points you have, the fidelity of the data becomes higher. So if you collect data every second from thousands of sources that are running on your system, you have higher fidelity data. So when you have more data, you have higher resolution, so which provides you better insights. Also, your sampling, you are not missing the unknowns. In some cases, what happens is you kind of feel, I'm an expert, I worked in this field for a long time, I know what are the important metrics for me to monitor. But when an outage occurs, and especially if it happens at 3 a.m. in the morning, you don't want to be running behind something that you don't know doesn't exist on your dashboard. So always try and collect as much data as possible from as many sources. You never know what is important. Make your troubleshooting future-proof. You don't want to leave any speculation when you're trying to find a root cause. You want to know exactly what went wrong, so the next time it is not repeated. And also, the more the data, with all of the AI that we have at our disposal these days, you can really generate a lot of summarized information for you to know, how your system is behaving, how are the trends, do you need to scale up, do you need to scale down, and all of those aspects. The other aspect is that the data and the new rules of data is changing. Like I mentioned, in the past, it was good enough for you to collect what is important to you or what you knew was important. But right now, I think what is important, you collect everything that is available, because when something goes wrong, you want to have the maximum visibility. No artificial limits. In the past, for whatever reasons, because of centralization of data, you had to pick and choose what you want to store. But now, there are tools that are providing you a distributed architecture. You should not really pick and choose, or you should not really need to pick and choose. So basically store everything for as long as possible. And then finally, the real impact. What does high fidelity data do to you? Finally, what's the outcome? Is that you can potentially have 80 to even 90% faster resolution times. You can catch micro anomalies in your system. So it might not really be an alert. It might not be something that is considered as an incident. But if you could see it today, you might prevent that incident that may happen tomorrow. And also, reveal based on historical patterns what holds for you in the future. So these are the real impacts and why high fidelity data is really, really crucial. So just to give the definition, I think I mentioned it. Instead of collecting data at 10 seconds or 60-second samples, can you collect them every second? Instead of collecting handpicked metrics. So for me, the CPU is important, the memory is important, this application is important, the errors are important. Instead of collecting partial metrics, can I collect everything that is available? Instead of having the data for just 7 days, can I actually have data for a longer period of time, which helps all of your AI, based models to find out some insights about your system. So again, the previous, let's say, equation of observability was what metrics do you have, what logs do you have, and what traces do you have? And I think going forward, and I think it's already started today, the new observability equation is going to be all the data put together. You have metrics, logs, outputs, any kind of data sources. But can we actually have more context? What is the metadata associated with these metrics, with these logs, with traces? What are the real business level KPIs, etc. And then finally, add the intelligence with all of your AI. So going forward, all of the observability solutions will fall into this model, where data is just one piece of the puzzle. but more importance will be towards context and intelligence. Now, quickly, some very quick introduction on NetData. So NetData is an observability solution, primarily targeting infrastructure monitoring. We can monitor anything that comprises of your IT and network infrastructure, from virtual machines to servers to Kubernetes clusters to network devices to cloud deployments, IoT devices, you name it. And we basically can monitor everything with basically a single command installation, which takes less than a minute to install. What we basically collect is metrics, logs, run out of the box anomaly detection, do performance monitoring, and integrate with incident management solutions like ilert, right? So finally, all of the alerting, all of the anomaly detections that we do, we allow our users to integrate with their incident management of choice. What makes NetData different? I kind of brought this up on the previous slide of high fidelity data. So by default, once you install NetData, which takes about a minute, we collect every metric every single second. So in terms of granularity of data collection, NetData is the absolute best. There is no other solution that can do data collection at this scale. We also create automated dashboards. So we collect thousands of metrics from any single system. So once you install NetData, we collect close to 4,000 metrics on an empty virtual machine. And we created automated dashboards out of all of these metrics. So there's no need to pick and choose. We also ship alerts out of the box. This is where an incident management system like ilert comes into the picture. Because the system is kind of zero config out of the box. So once you set up the system already starts identifying any issues based on the alerts that we ship. And a solution like ilert kind of fits perfectly into the picture. So it can receive these alerts, add some intelligence on top, and kind of provide the next steps of incident management response. The most important thing is, even though we collect every metric every second, all of the data is always stored on the user premises or the customer premises. It's a fully distributed solution. So we don't centralize data. This is one of the reasons why we are able to collect every metric every second. And also we are able to provide unlimited retention, for example. All of the other aspects kind of are side effects of our unique distributed architecture. That's what I'm alluding to next. So the way forward for an unlimited scale of your infrastructure has to be decentralization. Most of the observability solutions that I was talking about in the previous slides are centralized. So you either centralize the data to their cloud infrastructure, or you centralize data within your infrastructure, but all of it is always centralized. So the modern systems are fully distributed in nature. And so it brings an automatic question on why do we force the observability to be then centralized? Can't everything be distributed? So if my applications are running at the edge, can my observability also be running at the edge? So why the centralization points fail is because there is a single point of failure. There is exponential cost of moving data outside and storing data in a vendor's infrastructure. There's also bottlenecks when it comes to cross-team kind of collaboration. Also data sovereignty. Do you have, or do you want to have control of all of your data versus ship the data elsewhere and rely on compliance aspects to say that the data is safe? And also the query performance degradation at scale. So maybe when you have 100 systems, 1,000 systems, the performance is good, but the moment it goes to tens of thousands or hundreds of thousands of devices, there is degradation when it comes to centralized systems. So when you basically use a distributed solution, you could reduce your data transfer costs by 90%, make your mean time to detection about 80% faster. The teams can kind of operate independently. So depending on the data center, or if a team is a database team or a network team, can kind of locally manage their observability and troubleshooting infrastructure. So just to show quickly how the distributed architecture looks, each of these components are Netdata agents. You deploy them across your infrastructure. It could be on a cloud provider or your private DC. You can create local centralization points. So the data is still on your premises. So you keep them lightweight by collecting data and shipping them to a local centralization point. And you use Netdata Cloud to basically look at aggregated dashboards. So everything end to end across your infrastructure in a single pane of glass. And all of this while us not storing any of your data, whether it's metrics or logs. All of those data points are still within your infrastructure. And that's where we kind of feel this is a unique architecture. Now, what each of these agents does within themselves is basically auto-discover metrics, collect all the metrics, detect anomalies. So the machine learning is run at the edge. For every single metric, we run a tiny machine learning model at the edge. We basically put learning based on the previous data that is being collected. We have alerts that are evaluated at the edge. We have a scoring engine, a query engine, which is where the Netdata dashboards basically show up. They are real-time queries on demand. And then finally, the streaming, which is if you don't want to run the health checks or the machine learning or even data storage on the agent, you can stream it to another Netdata. It's called a Netdata parent. It's the same software, just configured as a parent. All of this, so finally, what does it bring in terms of KPIs is that you deploy it real quick. The resource footprint, even though we collect everything every second and do all of the magic at the edge, is 75% lighter. Very quick mean time to resolutions, 50 to even 80% quicker. You really, kind of cut down on your monitoring costs, 80%, sometimes even 90%, depending on what observability solutions. And we collect, like I mentioned, at least 50x more metrics on any of your hosts. We also collect 30 to 60x more granular metrics. So that's where we are able to provide more data towards troubleshooting. And that's where when we create alerts and ship it towards an incident management system like the ilert, we have more granular data to make meaningful resolutions to make. Last but not the least, how do we use AI within Netdata? Like I mentioned, we use unsupervised anomaly detection at the edge. So each Netdata agent kind of runs very tiny machine learning models for every single metric. So if you were collecting 5,000 metrics, there are 5,000 little tiny machine learning models so that the anomalies that you detect are actually localized. So you don't want to put all of the data centrally and then try to analyze your anomalies across your infrastructure. You want localized anomalies to be detected. Like I mentioned, for every metric, we run individual anomaly detections. Also, it's available everywhere on our dashboard. So anywhere that you look at on every single chart, we kind of point to you that your system is behaving differently. So you can look at that data and try and see how the trends change. What is it that was happening? Did I deploy a new software? Is this the reason that suddenly my trends have changed? Do I need to make any changes, even without reporting an alert? So you already have all of the insights on your dashboard. Finally, a scoring engine. So when something goes wrong and an incident is reported, you're able to kind of highlight the timeline when something has gone wrong. And Netdata will tell you which were the related metrics that behaved anomalously or behaved similarly during this time. So which helps you give a direction towards your troubleshooting. And then finally, of course, with the anomaly detection and the metrics correlation tools, you can run your root cause analysis multiple fold quicker than most of the other solutions. And all of this enabled by the high fidelity data that we possess. That's basically what I had. And Daria, I don't know if I was on time or did I take a little bit longer?
You
Try to.
actually were even a little bit shorter, but it's fine. Thank you, Satya.
Thank you.
Thank you very much. It was very educational and interesting, Satya, and I hope it was insightful for our attendees also. We have a Q&A session. Please feel free to drop your questions to Satya or to Birol or to both speakers right in the Q&A session, and we will cover or do our best to cover them all. Please don't be shy. And Birol, I'm passing the mic to you.
Yeah, thank you, Dasha. I can already see that there are a few questions in the QA, and we'll handle them after the presentations. Thank you, Satya, for your presentation and for your insightful talk. And it's really nice to have a joint webinar with you. And I think it's really impressive the way NetData emphasizes this like decentralized architecture. And I saw a talk from Costa when I met the NetData team in London, and I saw a talk from Costa where he was showing us how you guys do anomaly detection on the edge, and while having like 6 models with overlapping time periods in parallel. So that was really impressive to see, and while at the same time really consuming very little resources, right? So you're doing like you're calculating metrics, you're collecting data, and then you're doing anomaly detection at the same time with very little impact on the host itself. So that was really, really impressive to see. Yeah, so now I would like to bridge the gap to incident response, right? And let me share my screen before I proceed. So I guess you guys can see my screen now.
Yeah, all good, Birol.
Perfect. So like Satya mentioned, we serve as like the central dispatcher for any kind of critical information that can occur like in a company. And for this, we integrate with like hundreds of different tools, and one of them is the partnership that we have with NetData. So we integrate with monitoring tools, with ticketing tools. We also provide dedicated hotlines to our customers that they can use to report incident manually and route them to the correct to the right people. And as opposed to observability, we think that alerting and incident management and incident response has to be centralized, because what do you need for incident response? First thing is you need the data that is like that needs immediate human attention. These are usually alerts from monitoring tools. And then the second thing you need is all the information like related to who is related to people, like who is responsible for this incident. How can I reach that person? What do I do if that person doesn't respond? Are there any other devices I can try to reach that person? Is there an escalation? Like how long does the person has time to acknowledge an alert, right? So what we're essentially doing is we're connecting people with the systems that they operate. And because there's usually a very high overlap when you're a team of let's say a DevOps team, like you're not only looking after like one single system, there are multiple potential sources, and all the people related information, all the information were and that can also like change at any point in time. Like I can be on call today, I can have a private emergency, and I can ask a colleague to take over, right? So these things need to be very easy to change, and that's why we think alerting has to be done centralized. And this is where we come in. We serve as a central dispatcher and bring attention to events that need immediate human attention. And on top of that, we do a few more things, right? We are a like unified platform for incident response, and we like to cover the entire incident response lifecycle. So this starts with preparing yourself for incidents. What does preparation mean? You basically set up protocols to immediately like contain an incident. And in practice, preparation means trying to answer the questions that you would usually answer when you are fighting an incident. Like when you have an incident, you need to know who is the right team. And within that team, who is the right person? How can I reach that person? Do I have any playbooks? And with preparation, you try to answer these questions in advance and like set up on-call schedules, do a proper mapping between the services that you provide and operate and the teams that are responsible for those services, setting up on-call schedules, setting up escalation path. And then the next step in the incident response lifecycle is like responding to incidents. Whenever an incident strikes, you need to do three things. One, the first thing is like you triage the incident to understand like what's the impact? Is this a real incident? Does it have business impact already? Or is it going to have business impact if I do not act immediately? And the goal here is really, like, and I think Satya was mentioning this as well, like if you want to, do I stop the bleeding? Like, do I focus on stopping the bleeding immediately? And I would say yes. So the first thing you should do is try to minimize the impact, and then maybe collecting data for root cause analysis and so on and so forth, right? And then once you assess the incident, yeah, like you like the next thing you want to decide is this something I can fix on my own, or do I need to invite mobilize additional responders and then collaborate with them to fix the incidents. And the next thing is like incident communications, communicating incidents to stakeholders, because incidents are like, especially IT incidents, they affect the entire value chain. So it's not it's not it is not only affecting IT. It can affect like an incident with a critical service can affect an entire department. Like if you're a logistics company, it can affect your logistics fleet, right? So that's why it's important. You also need to communicate with your like users, with your stakeholders, and these can be internal to the companies, these can be external people, and we provide also a way to do this in the platform. And today we're going to cover a few AI use cases across the stages of incident response. And namely, we'll focus on the response phase, and I'll show you how you can reduce noise through intelligent alert grouping, and also how AI can help with communicating incidents. And also I'll give an example, like once an incident is over, you want to use this incident as an opportunity to learn from it, to take actions to prevent this incident from happening again. This is where postmortems come into play, and I'll show you how AI can also help you with postmortems. I'll provide an example how an AI can just streamline the process of preparing for postmortem meetings and creating postmortem documents. But before I start, I would really like to showcase the integration between NetData and ilert. After all, this is a webinar about NetData and ilert, right? So let me show how the integration works. And for this, I'm going to simulate a basic alert. And before I do, let's go to the NetData console. So I have set up a sample VM, a sample agent, and I've pre-configured ilert as an integration for incident management. And just to show you how straightforward this is, so when you create a NetData alert source in ilert, what you will get is an API key. And when you want to add that API key into ilert, you go to the alerts and notifications section in NetData, and all you need to do is really enter this API key, and that's it. Then you have a very basic setup for alerting, and all the alerts, or the ones that you select, are going to ilert, and then you have all the capabilities that I'm going to show you. For this, again, we're simulating an alert. Right now, there are no alerts. And what I'm going to do within NetData, within this sample node that I've configured, I'm going to change a trigger and basically reduce the threshold for a critical situation. In this case, it's the CPU usage. I mean, you can debate whether you should really get an alert about CPU usage when your CPU usage hits 80%. Probably you've done a few things right, you have done the sizing right. So it's debatable whether that should be something that's a reason to wake you up 3 a.m. in the morning. But let me now change the threshold like ridiculously low, just to provoke an alert. I'm going to change it to like 5% and submit this change. And I know that, let me change the camera as well, because my phone is going to ring anytime. So now I'm getting a call. You're not hearing the call, it's on vibration, but let me put it on speaker.
The subject is raised to critical system CPU utilization equals 11.89% on 172-31-0-42. Press 1 to accept the alert. To mark the alert as results, press 2. To escalate it to MRAVE power, press 3. If you don't want to respond right now, just hang up. This is ilert. You have accepted the alert.
So we've just received an alert from NetData, and you saw like it was like immediately, and I immediately received a phone call. Like usually you wouldn't probably get a call immediately. Usually you would like start maybe with an SMS or push notification, and we provide multiple channels. We support multiple channels, and these are all managed in your individual notification profile, where you can just set up basic rules how you would like to like get alerted whenever there is an alert assigned to you. And one thing that you probably notice is I was asked to acknowledge the alert, and that's very important, because acknowledging does two things. It wouldn't call me on my other devices when I acknowledge an alert, and it would also not escalate the alert in the escalation policy, right? It wouldn't alert my colleague. And that's also one reason why, like, usually the person that is taking the call, the person that is getting the page, has also a high incentive to acknowledge the incident, because if they don't, then like it will wake up their colleague, right? And imagine this, usually like incidents happen usually like at the worst of times. So maybe you're sleeping, maybe it's 3 a.m. in the morning. So yeah, we've acknowledged the alert, so it won't escalate further. And then by the time I've turned on my laptop, and first thing I want to do is like triage the incident. And let's assume like this CPU problem is something that is that's a real incident. It has a real business impact. And let's assume that this alert affects our all our payment APIs. We are an e-commerce company, and we notice that all our payment methods, all the payment services that we provide, are like responding very slowly because we have like very, very high CPU usage. And what I'm going to do is I'm going to turn this alert into an incident. So I'm going to create an incident. And again, this is the first part where I'm like using AI for this, just to help me create the incident message, right? Because it's a stressful situation, and actually what I really want to do is like solve the problem and resolve the incident. But then I do have another responsibility to inform any potential stakeholders, customers that are affected by this incident, right? And we make that very easy, because like if I respond them proactively, not only will this like increase trust with them, it will also like help me do my job better, because there won't be like any inbound queries, any inbound like hopefully no support requests, no calls asking, do we have a problem? Where are we with the resolution, and so on and so forth. So let's assume we have this alert affects our payment APIs, and what I'm going to do is say like payment APIs are like very slow, right? And I don't want to spend time on the messaging. That's why where an LLM comes in very handy. So I asked our built-in LLM to generate an incident message for me, and it starts with like drafting a professional like incident. Payment APIs are experiencing slow response time, and it also understands like at which stage of the incident resolution process we are. Like we're still investigating, and it also understands that slow APIs, like slow response time, doesn't mean it's a complete outage. The services that are associated with payments, and this selection has been done automatically because I was like saying payment APIs, and we in ilert there's a service catalog with like customer-facing, business-facing services, and these services have been selected automatically. Let's turn off notifications for a moment, and we can see that like this incident, when I like create it, it will appear on 6 status pages, and among them is like one public status page. And let's have a look at the public status page. So it immediately turned yellow, and we can see that the payment services on this status page are experiencing an issue. The next step is maybe I need additional help for this incident, right? I can see like, and we mentioned this in the beginning. When you have an incident, the first question you ask yourself is, okay, what has changed? Like, what could possibly lead to this incident? And usually, incidents are caused by like software changes, patches, infrastructure changes. And what ilert also does is, ilert is connected with your like CI/CD pipelines, and we can see a selection of 3 deployments that might correlate with this incident, right? And this correlation happens like based on service ownership, based on time. We can see, for example, there's a deployment that occurred 19 hours ago on the same team to which this alert source belongs to. So it might be the root cause for this incident, and we can even go into GitHub and like just have a look at the PR that was merged, and then maybe decide like to take action, roll back. But of course, for this, I might need additional support, and I'm like inviting another responder, Andreas Bauer, and like what it will do, ilert will alert Andreas in the background, and once he joins, we will have a war room Slack channel where he will be invited automatically. So every additional responder I invite here will be automatically invited to this Slack channel, and then we can collaborate on this alert. So I'm not going to show you the Slack part of this, but basically there is a war room that was created specifically for this major incidents, and what we're also doing is we're like continuously posting any updates to this Slack channel whenever we receive a new update. Okay, let's assume we have identified the root cause and we've actually fixed the issue. I'm going to like update the incident, fixed everything. Thanks. Again, let's use ilert AI to really to quickly update the incident. And what it does is, again, it like formulates the message for me, the incident message, so I don't have to spend time in finding the perfect words for this update. And once I click update the status page, this information should be immediately reflected on the status page again. It's not entirely resolved. It's still monitoring. Like usually when you fix something, maybe you want to give it some time and see like if it's really fixed. And what I'm now going to do is, like, because we have fixed the underlying issue, we should expect that like NetData is capable of detecting this fix, right? Let's go back to NetData. Again, I need to use fake values here, but if we fix something, we would expect that the underlying symptoms that they go away. So let's say the CPU is now healthy again. I'm going to change the trigger in NetData and go back to ilert, and like within a few seconds, this alert should be resolved within ilert, because NetData tells us that the CPU usage is not critical anymore. Now you see it's now it's resolved, and we can see like that we received the resolve event from NetData. And one thing I didn't show you is like whenever you have an alert, we also provide you with additional information that we receive from the observability tool from NetData. For example, like there is a link that leads directly to NetData to the alert, or there is also another link that leads you to the rooms in NetData where this alert comes from. Yeah, so that's the first thing I wanted to just. Now I'm getting a call. Let me reject the call. that's the first thing I wanted to show you in this demo, how basic incident response works. And we also saw that, let me completely resolve this incident. And we also saw that we can use AI to very easily like communicate incidents to stakeholders. Let me look at the time. It's 12:49, right? So I do have some time left. Now, I would like to show you a very basic demo of how you can use AI to intelligently group alerts and reduce alert fatigue. And let me start with a few made-up examples, right? So what I'm going to do is I'm going to switch to Postman. Here I have like prepared just a few alerts, and I have an alert source where I have enabled intelligent alert grouping. And let's assume we're in an office and the coffee machine on floor 2 is broken. It doesn't work anymore. So that's the underlying alert. And let me send this alert and go back to ilert. And I would expect, because this is the first alert, it doesn't group anything because it's the first alert, right? And then now let's find another way of like formulating this alert. Alert coffee machine on floor 2 is taking a coffee break. So it's, again, the same underlying problem. It's similar to the first one, but it's not the same text. So we're not looking at textual similarity. We're really looking at like a semantic similarity. So when I send this alert, I would expect that this alert is aggregated. And we can see here, no new alert has been created. Switching back to Postman and going further, let's try to be funny and let's say instead of coffee, we're talking about no Java from the Java machine. Floor 2 coffee maker is down. Let's see whether it will detect that this alert still belongs to the previous one. Send this request, and then we can see it's now, the counter went up to 3, so we have aggregated 3 events for this alert. Now let's come up with a counter example. Let's assume it's not the coffee machine. Now the water cooler is also broken. It's a different problem, right? And we would expect a different alert to be created. Let me go back. And boom, we have a new alert, because a water cooler is not a coffee machine. So that's a different problem, right? So you would expect that there is a new alert being created. And now you might think like these are like not technical examples. My alerts are about like CPU usage. My alerts are about hard disks. This wouldn't work with technical terms. And let me show you a counter example. Let's assume we have an alert that says the hard drive is full. When I submit this to ilert, again, a new alert is being created. The hard drive is full. And then let's try rephrasing this alert by using like completely different words. Instead of saying the hard drive is full, what I'm saying is the storage capacity has reached the limit of 90%. So if you look closely, there are no common words between these two alerts. And if you look at the alert, you can see that there are 2 events. The hard drive is full. The storage capacity has reached the limit of 90%. These 2 events, they have been aggregated because we look at the underlying semantics of the alert instead of like textual similarity. And this is powered by so-called like text embedding models. These are pre-trained models on like general purpose data that are capable of understanding the semantics of any piece of text. And that's why they are aggregated here. So that's a different approach to intelligently group alerts. Now let's take this example even further by looking at real alerts from Netdata, right? So for this, what I did, like we took some existing alerts of our customers, we anonymized them. And what I'm going to do is let's go to ilert again, and let's look at the alert grouping configuration of our Netdata alert source. So right now, we have not, no, there is alert grouping enabled. So let me disable alert grouping on this Netdata alert source. So every alert will create a new alert, so there is no grouping. And I have prepared a data set with like it contains thousands of alerts, but let's take maybe 100 alerts and see how many alerts are being created. And like before I do, let me also make sure that I don't receive notifications, because I don't want to receive too many notifications. I'm going to mute myself because notifications are not important right now. Let's say I'm going to mute myself for 30 minutes. And I'm sending 100 alerts to this alert source in Netdata. Again, this is simulated. These are but these are real alerts from Netdata. And if we look at the alert source, we can see like alerts popping up, and even lots of alerts. So and let me like, while these many alerts are being created, let me just have a look at how many alerts we have. Like we have over 43 alerts, and I believe the number is counting. It's 50, so on and so forth. So as you can see, there is no grouping involved. And I'm going to like resolve these alerts one by one or in bulk, like one page by page. And then in the meantime, I'm going to enable intelligent alert grouping on the alert source itself. So resolve these alerts, resolve. Now going back to the Netdata alert source, I am going to enable intelligent alert grouping. And when we look at intelligent alert grouping, there's one important parameter that you can set. It's the similarity threshold. It's a number between 0 and 1. And to make it easier to set the threshold, what we do is like there's a slider, and you can see the impact of this setting on the grouping based on the past 30 days. So let's keep the default. And then like it gives us an idea how it will cluster alerts. Like for example, there's this alert from Netdata where we have like 102 very similar alerts in the past 30 days. And another important setting is the grouping window. So you might want to start with a grouping window that's not too high. Let's set it to 50 minutes or 5 minutes, because if you set it to 5 minutes, you are sure to catch all the instances of alert flooding that are obviously like they should be grouped, right? When you have 10, 15 like CPU alerts in a very short period of time, they are likely caused by the same root cause, so it's very safe to group them, like if they have like semantically the same meaning. But of course, you could have like completely different alerts that are falsely grouped together, that maybe even the underlying root cause is even across like different teams, right? And you want to avoid that and maybe like start with a window that's not too high, just to make some experience with the alert grouping. So I'm going to set it to 0.75 and 5 minutes. Let me again check whether now all alerts are gone. There are 25 left. So as you saw, we had about like 100 alerts, and now I have enabled intelligent alert grouping. And now let's replay the alerts again. So I'm going to run this Postman script again and fire 100 alerts against ilert. So we're like bulk sending alerts to ilert, and this should be completed very soon. So it goes on up to sends 100 alerts. Now it's done. Now let's have a look at the results. So we have like while alerts are still being processed and coming in, we can see that like we're not in the hundreds anymore. We're probably in the tens, like about 10, maybe a little bit more alerts. And let's pick an example where there were many alerts aggregated. Let me again refresh. Oh, I'm sorry. So if I look at the alerts, see the aggregation count, we have 6 here. We have 19 here. So let's have a look at this specific alert. So there were 19 alerts that were very similar to this one. And if we look at it, you can see this is apparently a disk problem. One alert says estimated time the disk will run out of space. Another says total space utilization of disks. So these are obviously all hard disk problems. Some of them are set differently, like formulated differently, and that's why they have been grouped. So that's how intelligent alert grouping works with ilert. And last but not least, I wanted to show you postmortem. So I'm not going to run through an entire example of postmortem generation, but just show the basic the basic workflow for creating postmortems. You remember we had an incident that we've created like 10 minutes ago, and like now it's resolved. And there was like one alert linked to this incident, and there was even a Slack channel that we created and collaborated on. And once the incident is over, maybe the next day, you are the person in charge of like preparing the postmortem meeting. And when you prepare a postmortem meeting, what do you usually do? You try to build an incident timeline. You try to collect all the decisions that were made between the team, and these decisions are usually documented in the Slack channel. And these incident war rooms that you can have in Slack or Microsoft Teams, they can get pretty long. And what we do when we generate a postmortem, we like ask you to like select the alerts that you would like to consider. So it will create a postmortem document by taking into account the machine generated data. So all the alert data, notifications that were sent out, the responders that were included, all the incident related data. So the status communication that happened, but also it will also look at the chat channel. And the chat channel is really a gold mine for creating a postmortem because it contains like things like what was the root cause, right? Because these are the things that you talk about when you collaborate on an incident. What was the root cause? What's the business impact? What actions like do we need to take now? Like in our case, it was rolling back a deployment that led to this incident, right? These are usually documented in the chat, but of course it's unstructured. So when all I have to do is I can click on like generate a postmortem, and this takes a few minutes. And once it's done, it will compile a document that looks like this, right? It builds an incident timeline for you based on all the machine generated data. It documents impact, root cause, and action items. And this entire document was entirely generated on a real incident with ilert AI and the underlying LLM we use for this. Of course, this is not supposed to replace the postmortem meeting, but it gives you a head start. It's an 80% version of the postmortem document and gives you the freedom to focus on the remaining 20%, which is the valuable part in postmortem's creations, is like how can we take this as an opportunity for organizational improvement and like prevent this incident from ever happening again. Yeah, so these are the things I wanted to cover in this webinar. So we looked at like responding to incidents, communicating incidents, and learning from incidents. And we had a brief demo of how we can use or leverage AI to improve the three steps. How are we doing time-wise, Dasha?
We have some time below. Thank you very much for the live demo. It was really great to see how these two tools can work together. First of all, let me remind everyone that we have a last chance to answer the questions in the poll. We're closing it in a few, I would say, seconds. And let's switch to the Q&A part of our webinar. We have a few questions in the Q&A session. I will read out the questions and address them to our speakers. So the first question is, can Netdata and ilert be integrated to service management tools like ServiceNow? I think, Birol, you are probably the best speaker to talk on this.
Yeah, so one thing I didn't talk about in the introduction is you could have Netdata as an inbound source. And we also have this notion of outbound integrations. And outbound integration is you have an alert and now you want to do something with that alert automatically or manually. And this manual actions could be I want to create a ticket in ServiceNow, right? So in that way, you can essentially connect NetData with ServiceNow through ilert, because that could be part of your incident response. Part of your incident response could be, okay, whenever there's an alert, and this alert is actually an incident, so it has business impact, I need to create a ticket. I need to log this in ServiceNow. You can do this manually through an alert action. If this was an alert action, we would show you the action that you configured on the NetData source. So let's again see, for example, I think this NetData source doesn't have any alert action. So it would appear here and have an action that says, create a ServiceNow ticket, right? And let me show this to you real quick. Let me add an existing ticket, an existing alert action, create ServiceNow ticket. So if I do this, every alert that is created by NetData will have this alert action where I can create a ServiceNow ticket.
Thank you very much for Birol. The second question we have, what role does auto-discovery play in observability and incident management? Satya, I would like to address this question to you.
That's a very good question. I mean, Birol gave a very good demo of what you can do once the incident comes in. But I think what is the key aspect is how good or how on time are these alerts being received from the observability solution. And that's where I think, when you have auto discovery and you collect all the metrics out of the box and you don't need to pick and choose, you have a higher probability to kind of indicate certain issues that your system could be encountering. So it might not really be an outage yet. It might not really be a slowdown, like Birol mentioned. The earlier you get an indication that something could be going wrong or something could be an anomaly, it just makes it easier. That's where I think collecting as much data out of the box, you don't necessarily need to know that some data point is important or some metric is important. So if you're able to auto discover once you deploy, whether it's system level, application level, network level, or even hardware level metrics that you collect, and you're able to alert on them, I think you have the bigger probability of identifying the issue before it becomes a big incident. That's where I think it's really key that you have a solution that's able to auto discover and collect as many metrics as possible.
Thank you very much, Satyadeep. Another question I think we have for both speakers. Which LLM model are you using on the backend? Is it self-hosted or online? Birol, may I ask you first answer this question, please?
Yeah, sure. So this depends on the use case. If you look at the use cases again, we saw one use case, intelligent alert grouping. This is entirely self-hosted. So, and we're not using a fully fledged LLM. We're hosting a text embedding model. So that's one part that is being used like in these LLM ecosystems, where we turn a piece of text into a vector, and this vector is a mathematical representation of that piece of text, and the distances of these vectors between each other capture the semantic relationship. So for the alerting use case, it's entirely self-hosted, and that's also very critical for us because we cannot afford to have an external dependency for a very critical flow, which are processing events, right? Because we process millions of events on any given day. And that needs to be very fast. And this is where we're completely relying on a self-hosted approach. It's different with the incident communication use case that I just showed you. And the underlying LLM being used depends on the region of that customer. So if it's a customer based in the EU, we're using Claude hosted in Frankfurt by AWS Bedrock. If it's for example, a US customer, we're using the OpenAI models, and it's the same for creating postmortems. So for these tasks that are manually triggered, that are not like where we don't it's not a high throughput use case. We're relying on these external LLMs. But for the alerting use case, we're completely relying on self-hosted text embedding models.
Just a short clarification below before we switch to Satya Deep.
Mhm.
Is it available on multiple languages or English only?
Um, that's a question for me, right?
Yes.
Yeah.
That is the
Yes.
question from the Q&A, clarification regarding the previous
Okay,
question.
okay. Got it. Okay, so first, the ilert platform is available in 2 languages, in German and English. Now the question whether the AI use cases are available in multiple languages. These 2 ones, communicate and creating postmortems, they are available in multiple languages. So if I typed something in in a completely different language, it would generate the incident in that language. With intelligent alert grouping, it's a little it's trickier. So right now, the intelligent alert grouping is using text embedding models that were mainly trained on English language. And it's because, like, in our experience, using text embedding models that were trained on a variety of languages, they don't produce the same results. So yeah, alert grouping, not yet. It's English only, so your alerts have to be in English. But the other use cases, it supports a variety of languages.
Thank you, Birol. Satya Deep, would you like to add something regarding LLM models and AI in general?
Oh, yes, definitely. So I think I covered more the ML aspect of anomaly detection, which is where, you collect data, you identify and detect anomalies, basically present it on the dashboard. But we have a new functionality called NetData Insights, which is very much like Pirol was showing on the screen. So given the amount of data that NetData has access to, it doesn't store it, but it can query a lot of data. Uh, in the past, what was available was these dashboards, and the users can see the trends because the dashboards go up and down. It's quite easy to figure out. But with the NetData Insights, we are kind of embedding all of these LLMs, also hosted on AWS using Bedrock, where we are able to generate insights. So if you want to generate a report over the last 1 week for your performance optimization, or basically figure out your cost computation, your capacity planning, and all of that, NetData now has a way of you doing this with simple LLM, right? English language. So if you say, over the last 1 week on this data center, how has my performance been? What's my trend been? How are the anomalies? So NetData has a way of reporting this to you as reports, which was missing. It's still an alpha feature, and we would be releasing this very soon. So I'm sure then also the LLM-based questions will be more relevant. So yes, I mean, I think we are very excited. I think the way both ilert and NetData kind of function, and the capabilities that we provide hopefully are going to be very aligned. Thanks.
Thank you, Satya Deep. I think the last question we can cover so that we fit the schedule. I see there is integration with Splunk. Will it provide the data for alert? I think, Birol, this is the question addressed to you.
Yeah, I believe we both have an integration with Splunk. So probably NetData has an incident management integration, because a part of Splunk is Splunk On Call, which is which falls in the same space of ilert. And we do also have an integration with the Splunk observability platform, where you can send all the critical events to ilert and be alerted about those critical events. And basically all the features I've shown you would also be available there.
Thank you very much. I think it's time to tell you the results of our poll. So just a reminder, the first question was, what is the biggest challenge in managing incidents? And actually, we had a very funny dynamics there. Now we have the major part of our attendees chose other, but then all results are divided by 20%, root cause runaround, teamwork, and communication with clients. So obviously everything is actually a challenge when everything is red. The second question was which incident?
Dasha, one thing I'd like to add is, so hopefully we saw today that I think, I don't know, probably NetData makes the second, like for finding a root cause easy with their like insights and teamwork. You just saw that, how like you can orchestrate and mobilize responder and run an incident in iLert. I didn't show the Slack and Microsoft Teams part of it. And of course, which one thing I find insightful is communicate with clients. That's actually the incident communication part in iLert. So hopefully you were able to see some of the valuable things in this webinar where you can like overcome these challenges. Yeah.
True. The second question was which incident metric is the primary within your team? Overall uptime was chosen by the majority. And finally, are you already using AI features in your incident management process? And the majority said no. Hopefully this webinar will change this. We hope you enjoyed this event. Thank you very much, Birol and Satyajit, for your insightful talks. And I think we can finish here. Thank you everyone, very much everyone who joined, and we'll send out the recording in a few days. Thank you, and see you again. Bye.
Thank you,
Thank you,
guys.
Michelle. Thank you,
Bye.
Satya.